Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Level 1, we had solved this question of largest area histogram. So let's try to revise what we had done here. So we had to find the largest area of the rectangle which is formed by a histogram chart. So what we did was we spread out the bars that we had. Okay. And once we spread out the bars till what what was the boundary? So the boundary was the next greater element to the right index minus the next greater element, next not greater element, the next smaller element to the right index, and the next smaller element to the left index, their subtraction minus 1. So that is what gave us this, right? So we had the formula and then we used to multiply that by 1. And we also had considered that there is a deep valley here, so whatever elements are coming here, they'll have their indexes of ARR dot length. So for 1, the index which is next smaller index to the just a minute, next smaller index to the right will be ARR dot length, and similarly for 2 it will be minus 1. What will be minus 1? The next smaller element index to the left. Yeah. So that was all about that question. So let's try to tackle the next question that we have, which is this sliding window maximum. So you are given a number n representing size of an array, you are given n numbers representing elements of an array, you are given a number k representing size of the window. You are required to find and print maximum element in every window of K. So suppose we have this array here and we are given the window size as 4. So what do we need to do? We need to find the maximum in this window size. So we'll consider 4 elements. So in these 4 elements, 9 is the maximum. So we print 9. Then we move ahead. So in these 4 elements, 9 is the maximum again. So we print 9 again in the result area. In the next, what do? We see that 8 is maximum, so we print 8. And in the next, we see 12 is maximum, and hence we print 12. So this is how we'll get the result array that we have here. Okay. So let's try to analyze this question first. Let's try to have this in Notepad directly. Okay, so we have, let me try to draw it also once. Just a minute, guys. Yeah. So first we have 2, let's say this is 2. Then we have 9. Then we have 3. Then we have 8. We have 1 again. And we have 7. So this was 8. So 7 will be, we draw 1 properly. We have 7, right? Then we have 12. And then we have 6. So this is 7, right? So we'll have 6 somewhere here. It's too much close. Let me take it. And then we have 14. After 14 comes 4. So we had 3 here. So 4 will, let's say, come somewhere here. Then 32. 32 will be this big line, right? Yeah, this is 32, then we have 0, then we have 7. So we already had 7 where here. So this is, let's say, 7. And then we had 19. This is 14. This is 32. So let's draw 19 here. Okay, then we have 8. So this is 7. Then we'll have 8 here. Then we have 12 again. So we had 12 earlier all this well. So this was 12, correct? This was 14. So this was 12. So we'll have 12 here. Somewhere here. Yeah. Then at last we have, oh, we missed 19. Okay, so let me write those elements. This is 2, this is 9, correct? And this is 3. This is 8, this is 1, this will be 7, this is 12, this is 6, this is 14, 4, then we have 32 here. Then after 32 we have 0. So we have 0 here. See. Then we have 7. And then 19. 8. 12. And lastly we'll have to draw 6, right? So we'll have 6 here. Let me have it drawn through a pen. Yep, so this is the graph that we wanted. Let's now try to analyze it. So first what we can do is that we can try to find the next greater element to the right. So that's the hint that we have. So what we can do, we can try to find the next greater element to the right. So what if the next greater element to the right of 2? So to the right of 2, the next greater element is 9, right? And we don't have to find the next greater element uh, of of the whole, this array, right? So we have to find it for a particular span. So let's consider first the span is this. So the next greater element for this span, because k is 4, so it will cover 4 elements. So for this it is 9. So how did we get 9? So we first saw that the next greater element of 2 is 9, and the next greater element of 9 is 32 is 12, right? And 12 is outside this window. So what we did not consider 12, correct? So and then what we did, we moved further again. Okay, so let me move further again with this red and enclose four bars. So for this one again, the next greater element of 9 is 12. Okay, and 12 is outside the window because we are considering 1, 2, 3, 4, these four elements. So the next greater element will be the number itself. So what we will do, we'll try to solve it using pointers. So we'll try to solve it using mm, the sliding windows mechanism that we have. So let me try to initialize some variables. So we'll have an variable called I, which will give us the base, and then we'll have a variable called j, which will jump from one greater element to the next greater element. Okay, so so let's try to solve this now. So at the first, I will be at the 0th position, as well as j will be at the 0th position. And then what do we do? We find the next greater element of 2. So what is the next greater element of 2? It is 9. So j will move there. Okay. Once j moves there, what we do is we try to find the next greater element of 9. Okay, so the next greater element of 9 is 12, and 12 is outside the window. So we have to do these following actions. So we'll first have to have I and j, so j will keep on moving forward. So we'll have to bring that to the position of I for each iteration. And then what we'll have to do, we'll have to keep on jumping j till we find an element which is outside the window that we have. So for this case, the, ne the next greater element of 9 is 12, which is already outside the, sorry. So for this case, what we did is, for I is equals to 0, we found that the next greater element of 2 is 9, and that of 9 is 12, which is outside the window that we have. So we print a 9 directly. Okay, we print 9. So we'll get 9 first. Okay, let me have it here. And then what do? We consider this element now. So I will move forward now. So once I moves forward, what happens? We'll consider this window now. So what is the next greater element of 9? Next greater element of 9 is 12, which is already outside the window. So we print 9 itself. So for this iteration we print 9. And if you see, observe carefully, the next greater element of 9 is 12. So all these elements, right, will be smaller than 9 and 12, right? So 9 will and 9 12 will include all these elements that we have, correct? Just an observation. So yeah, so for the next window, we'll consider I is equals to 3. So for I is equals to 3, like J had went here once to 12 to check which is the larger element of 9, and then it came back again. We have to consider that, yeah. And then for this element, I for I is equals to 3, what do? We J had went here initially because next reader element of 9 is 12 and J goes there. But we have to bring back J again to the position of I. So for each iteration, we'll bring J back to the position of I. Right? We'll initialize J is equals to I basically. And then for this, mm, we can have this blue color, yellow color, and we'll have this as the window, right? One, two, three, four. Four elements are covered here. Let me try to have it up a bit. Yeah. So for this window, which is the next greater element of 3? Next greater element of 3 is 8. And which is the next greater element of 8? It is 12. But 12 is outside the window. So what we do? We first have I, right? I here. Okay, we have I already here. So J will move to 8 first. We change the color again. J will move to 8 first. Okay. And from 8 it will move to 12. But 12 we have to check if 12 is within the window or not. So 12 is not within the window. So what we do is that we come back again. Okay. So we come back to 8. So 8 will be only the maximum. Correct. So this is how we'll try to solve this question, like having two variables. So for that, what we require first is we require to find the next greater element to the right. So we have this code of largest area of histogram, and let's try to copy this and name it sliding window max. Okay. So for this sliding window maximum question, we have to find the right boundary, right? So it will be similar, the logic will be similar. So let me try to reuse that logic. So first let's try to get the right boundary that we have. Okay, why is it complaining? Yeah. So for elements to the right, we already consider them as array dot length. Like we can consider the same hypothesis like we had in the last question. Like we can consider a value here. So the number larger than 32 will be infinity, or we cannot have infinity, right? So we substitute that as arr dot length. So what we do is for for the last element we have arr dot length, correct, and we push array dot length minus 1 first, and we start iterating from dot length minus 2 to I, yeah, while stack is empty and array of I is greater than, right? Because if the element is greater than or equal to, then we pop. Otherwise, we push only. So we push only otherwise. So if stack is empty, then that element is the greater. So we put substitute array dot length, else we substitute array dot peak. So let's try to run this first for the inputs that we have. So we have an array of size almost 17, correct? Yeah. So the elements of the array are okay. So we'll also need to have the window as an input. So we'll first try to find the next greater element and then we'll find the window. 8, 1, 7, 12, 6, 14, 4, 32, 0, 7, 19 and 8, 12 and 6. Yeah, so for 2, the next greater element is 9, which is as index 1. So that is what we got. For 9, the next greater element is at index 6, which is this 12. For 3, it is the position. So 0, 1, 2, 3. So for 3, it will be 3 only, right? Yeah. So we have got the next greater element to the right, basically here. And now what do we need to do? We need to perform the iteration. So we iterate till when do we want to iterate? So we want to iterate till array dot length minus k. So we'll only have to iterate till here, right? Let me till we where we have the windows as 4. So but we'll need to take the input as k first. So we haven't taken the window size as input. Enter, let's say, window size. So int k. We have scanner. Okay. So we have this now. So once we get this, we'll iterate till here because it's of no use to go over this. Like we cannot form any groups after this, right? So after this we'll have a group of 4 of 3 and after this we'll have a group of 6. So the result array also that we'll be forming. So we haven't formed the result array. Okay, we'll form a result array. It will be something like this. Sk, right? So that will be of length minus k. Yeah. So we'll try to put the elements in this result array. So the result so we'll start the iteration from I and we'll have another variable initialized comma j is equals to 0, and for each and every time what we do first, before every iteration we just have j is equals to I because we have to catch those, we have to make them equal first. Then I will start acting as the base, and first what do we need to check? While right bound right boundary, yeah, so right boundary of j will give us the index, right? Index of the next greater element. So so while the index is less than I plus k, So till then what do? We just substitute j is equals to right boundary of j. Okay, and what are we doing here exactly? So for first, for the first one, let's consider we have printed the maximums, the next bit elements as well, right? So it's better to analyze it here. So we have this, the next bit element to the right, and for this we'll have this. It's just a matter of spacing now, or having those commas. Yeah. So these are the index, these are the array that we have. This is the next greater element indexes array that we have. We have it here, expanded. So what do we do is, in this loop, what do we try to do? First we equate j is equals to I, then we find a right boundary of j. So j will be 0 first. Okay. So right boundary of j meaning 1, right? J will be 0 first. So right boundary of 0 is 1, right? So 1, is it less than I plus k? Yes, it is less than I plus k. So I will be 0 and k will be 4. Yeah, so j is less than I plus k here, right? So if that is true, what do we substitute? We substitute j is equals to right boundary of j. Okay, so j will become, so let me have it here, j is equals to right boundary of j, meaning j was 0, so j will become 1 now, right? Correct. Right boundary of 0 is 1, so j will become 1. For the next iteration, what will happen is right boundary of 1 will check. So right boundary of 1 is 9. So right boundary of 9 is 6. So is 6 less than I plus k? No. Then what do we do? So if 6 is less than I plus k, we just put into the result array of I is equals to, what do we put? We need to put if 6 of I, while right boundary of j is less than I plus k, then j will keep on jumping. So we'll have to put ARR of right boundary of I, right? Something like this. What do you guys think? So we can have some more, configurations for this, more iterations for this, but let us try to think about it first, right? So we'll be having what in the window? We'll be having ARR of J into the window directly because we'll be getting that, not this, right? We'll be having ARR of J. Okay, because the jth index will be now having the next greater element. Yeah, so yep, I think this code might work, and what we'll do is we'll try to print this afterwards. So let's try to have it run for 70 into 9, 3, 8, 1, 7, 12, 6, 14, 4, 32. Okay, 32, 0, 7, 19, 8, 12, and then 6. Window size is 4. Oh, we got, yeah, so we'll have to, okay, we are iterating. So where did we get array index out of bounds exception? On line number 46. But we are stop. Okay, so I think we'll have to do add one more index here. Yeah, so this will be having ARR of for this result array that we have declared. Yeah, ek plus 1. So let's try to run it for index 17, 3, 8, 1, 7, 12, 6, 14, 4. Window size 4. Yeah, we let me check the output that we have. Like this is the output that we got, and just try to compare the output that these guys have. Yeah, so you have last three elements as 19, then three elements as 32, four elements as 32, right? 1, 2, 3, 4. Yeah, two elements as 14, two elements as 12, one as 8, and then two as 9. Yeah, so this is how we have solved this question about the sliding window maximum problem. So that's all for this video. See you guys in the next one. Thank you.